Hello and welcome to this video on graphing piecewise functions. To start off with, we want to think about just in general some definitions and some important information. To start off with, the definition of a piecewise function is basically a function that is defined by at least two equations, 2, 3, 4, etc., and each of which is going to be applied to a different part of the entire domain. If you don't remember, domain is all of the x values that a function goes through, and the parts of the x's that each function will go through will be different. Each function will be on a different part of the entire whole domain of the entire function. Now, these pieces that we're talking about, they could be linear, they could be quadratic, they could be any family of functions that you've learned about so far, and it will expand from there. But most of the piecewise functions that we'll be seeing in Math 3 are going to be of the linear variety. Because of the ability to be from so many different families, there's no one parent function for piecewise functions. So we kind of have to treat each one as a unique problem and graph it accordingly. We're looking at an example of just the function in front of us here. So as far as the parts go, remember f of x and y are basically the same thing. So I could think about each of these pieces as y equals x plus 2, y equals 1, and y equals 2x. To the right, we have some inequalities. Hopefully you remember how inequality symbols work. So if you read these three in particular, you would have x is less than or equal to -1 for this function. X is between -1 and 1. Notice these are both less than, no, or equal to parts in this second row for when y is equal to 1. And for when y equals 2x, x is greater than or equal to 1. So we now can look at the graph that would match these equations. So you can see if you can't see my dots here, I have a little black dot in the first one. So x plus 2 would be this black line, and it stops at -1 on the x-axis. So you can see where it stops there. And there's a closed circle because of this less than or equal to sign. So when you see less than or equal to or greater than or equal to, that means that you're going to be using a closed circle on your graph. And you might remember that from when you learned about graphing inequalities back in Math 1. And alternatively, our second equation has less than symbols. So if you have less than or greater than, those are open circles, just like we saw with inequalities back in Math 1. Sometimes you will have points on top of each other. So even though the red one, you basically have a kind of a red open circle right there, and then at the other end as well, because it's just flat line at 1 for the y-axis. You have the black point from the first function and the red open point on the same thing, so you can kind of just treat that as one big point and not have to worry about that otherwise. But then the 2x is not connected to this one, and it's kind of above it, and it's going off in its own direction. So a couple of different things to remember. So the idea of something being a function you've learned about before. One way you could tell is that we don't want to have functions kind of on top of each other going vertically, because you don't want to be able to draw a vertical line and hit more than one part of your function or functions. We don't want multiple y values for one x value. Now, we can get away with that in this place right here because this is an open circle, so we're not counting it, and then we have a closed circle above it. So if I drew a straight line down at x equals 1, I would only hit a closed circle once, and that otherwise I would be only hitting open circles. And so we have that pretty much done there. So we want to make sure we have functions. We don't want anything overlapping. Otherwise, we also want to think about whether something is continuous or not. Not something that we're going to be dealing with a lot in this course, but basically the easiest way to remember whether something is continuous is if you're drawing the graph of your function, if you can draw the whole thing without lifting your pencil or pen, it's continuous. The opposite of continuous would be something called discrete. and that is when you have separate kind of pieces that are all on their own. So this would not be a continuous function in total because this purple part is not connected to the other two parts. And those are the kind of the main intro things for piecewise functions. And that leads us into a couple examples we're going to be doing and graphing. And that will be doing them in a couple different ways and methods. So let's start with that now. So the first method that we're going to be talking about is we're going to be trying to graph the function down here at the bottom left. We have two linear functions with two inequality domains to go with them. So one way to do this is basically making a table, as you can see in the top right-hand corner here, and then kind of plotting our points between these two endpoints, and then the same thing for our second function. So first and foremost, we need to fill out this table right here for 2x minus 1. And so we can just grab a calculator to make that really easy on ourselves. So we're going to do 2 times negative 3 minus 1, and we'll just fill in these values as we go. So we have negative 5. And now that we know this, we know our slope is 2. So, I mean, they're going to be 2 apart, but we can kind of keep going to make sure we're doing it right. Well, negative 3 is next, so we can just kind of fill in the rest. And so we have the graph of 2x plus 1. 2x minus 1, I mean. And then our next one we can do in a different color. Our next function, if we move our calculator, is negative x plus 3. So that's what this table right here is going to be, negative x plus 3. So we can fill that in. We got 3, negative 1 plus 3 is 2. Negative 2 plus 3 is 1. And we're going to be just going down by 1 each time. And we have filled in our whole table. So now if we look at our function down here, 2x minus 1, the blue table, or whatever color you want to call that, is going to only be from negative 2 to 1. And you'll notice that we have these less than symbols. That means we're going to have open circles on the ends. So if we look up at our table, at negative 2, we should be at negative 5. So we could find the point negative 2, negative 5, 1, 2, 3, 4, 5, and put an open circle there on our graph down here at the bottom. So next, our other endpoint is a 1. So we can go over to our table. 1 comma 1 would be that point. So I can put another open circle there. And all I have to do if I have two ending points there is just connect them with a straight line. So I have the blue part of my graph, our function graphed, I should say. And now we can move to the second function we're using. So now we're going from 1 to 5, and we know it's linear. That's why I was able to connect these 2 points. So at 1, we're supposed to be at 2. And these are going to be solid point there, because we see we have a less than or equal to. So that's a closed circle. But this is going to be a less than symbol. So that's going to be an open circle. And so now our 5 should be at negative 2. So 5, negative 2, 1, 2, 3, 4, 5, 1, 2. And that's going to be a open circle. And we can connect those 2 points to finish our graph. And we have graphed our piecewise function right there. And we have the entire thing. We don't have any parts of our piecewise function that is just x is greater than a number or x is less than a number. Those were where your arrows in the ends come in because they're going to be going on forever. These 2 functions have starting and ending points. And you can definitely make these tables and then use your inequalities to graph them as points. And we can even graph all of the points between, say for the first function, from negative 2 to 1, we could graph 1, 2, 3, 4 points. 1, 2, 3, 4 points, and then just stop at those 2 endpoints. So that covers our first example. So we're going to do two more examples here. So let's flip to those now. So in number 6 we have here, let's zoom in a little bit. So for number 6, we are going to be graphing this a little bit differently. We're not going to use the tables again, but we're going to do it in a pretty easy way. So you'll notice that for this piecewise function, we have 3 inequalities that are all still kind of starting point, end point. And those points are what's going to be really important. So we're going to do this in 3 different colors. And so our first one will be blue. So basically what I'm going to do is put 0 into x and 2 into x to see what 2 points I'm going to get. So if I put 0 in, well, that's going to be 3 times 0, and just going to be the point 0, 0. If I put a 2 in for x, that is going to be 2 times 3 is 6. So I have 2, 6 as my ending point. You'll notice that we have a less than symbol, so this is going to be an open circle at 0, 0. And then 2, 6, 1, 2, 3, 4, 5, 6 is going to be a closed circle, since that's a less than or equal to sign. And we can connect those points. Okay, so we have our first part of a function graph using those endpoints. So second, we are going to use the 2 and the 4. But there's no x to plug into because we just have y equals 6. It's just a flat line at y equals 6. Meaning there are 2 points are 2, 6, and then ending at 4, 6. So we have also a open circle leading to a closed circle. So we have 2, 6 just on top of our other closed circles. That doesn't matter too much. And that's going to lead to 4, 6. So 3, 4, 2, 3, 4, 6. And that's a closed circle. And we don't need a ruler for that one. We can just connect those 2 points. So we have the second part graphed. And now lastly, we're going to use our last equation for the third piece. So 4 into x would be negative 4 plus 10 is 6. 4, 6, connecting to our other ones. And then we have a 6 going into x. Negative 6 plus 10 is 4. So we have 6, 4. And these are both open circles. Our first one is just on top of our other one, so that doesn't matter. But the 6, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4 is definitely an open circle. And we are going to fill in those purple points by connecting them on our graph here. And so we have the graph of that piecewise function by using our endpoints and substitution, which is a skill we all remember from past semesters of math. And we didn't need the tables, but it's still an option. You can still definitely make a table, and you have lots of experience making tables in prior classes. So moving on to our last piecewise function of these notes. And so we're going to move to our bottom graph here. So now we only have 2 functions and one where it's just x is less than 0. So let's go ahead and do this one now to finish up. So we have negative 2x plus 4 is when x is greater than 0. So if I put a 0 into x, negative 2 times 0 is 0 plus 4 is 4. So I have the point 0, 4. And that's going to be an open circle because of that less than sign. So 0, 4, 1, 2, 3, 4, open circle. And we have a x is less than sign. So you have two options here. Your first, since we know we're starting at a point on our line, we can follow our slope. -2 is our slope. M equals -2, which is the same thing as -2/1 or 2 over -1. So we can go down 2 and left 1, down 2 and left 1, and we could plot all these points like so. We could also just look at points to the left of it, since we're at x is less than 0, and fill in a table. We could use this left table right here. So we know that we're going to start at 0 and go negatives. So we already know that 0, 4 is a point. And so if you put in -1 into that function, you would get a 2. Oh, I actually graphed that wrong. So let's forget about that for a second. We went down instead of going up. It's going up 2 and left 1, up 2 and left 1. So it's going to be following those points instead. So if I go to -1, it's actually going to be -2 times -1, which is 2, plus 4 is 6. And then -2 will be 4 plus 4 is 8. That's off the graph, but we basically are going to be going and following our line like that. So that's what our real line is going to look like. And then lastly, our last function here, we are doing 1/2 x plus 4. So if we put a 0 into that, well, we have 0 times 1/2 is 0 plus 4 is 4. So we have 0, 4. So right inside of our first point, we can plot that inside of it. But now we have a kind of a weird thing happening afterwards. We have 1/2 times 3 is 3/2, or 1.5, plus 4 is 5.5. 3, 5.5. So we don't necessarily plot decimal points there, but we can try to do our best with it. But basically what I end up looking like at 3, going up 1, 2, 3, 4, 5.5, somewhere around that with a closed circle. And normally you don't want to graph in between points, so we want to have one between these two ends that actually is a solid point. So if I wanted to do that, I could just go down 1 to 2, or follow my slope and go up 1 and over 2, and that would lead me to the point I need. And that would be an ending point there, since that's an inequality that has an endpoint. And that's the general strategy for graphing piecewise functions. We've kind of had a preview of evaluating them in there as well. And we'll also take a quick look at applications in real-world word problems in future classes as well. But otherwise, that concludes this video. Thank you for watching.